Welcome back to Practical PyTorch. This is the last video of the performance playlist. Every fix so far tuned the framework. Today we open the door underneath it. Every fix in this playlist tuned the framework, the layers above the kernel. This short finale opens the door underneath it, the compiled kernel, and the CUDA C that writes one. Everything you tuned transfers, memory layout, launches, precision, compile lives above the kernel. The kernel itself is the boundary, where PyTorch ends and CUDA C begins. This playlist tuned the wrapper. This lesson opens the door under it. This video has 3 parts. First, the door at the bottom of the stack you already know. The kernel layer opens onto the CUDA course. Second, one op shown 2 ways. The same computation as a PyTorch line, them as CUDA C. Third, when to actually go down there. Profile first, because a custom kernel is the last resort. Part 1. The door at the bottom of the stack. This is the stack from the first performance lesson. At the top is your Python line. It calls down into an op. The op here torch.mul. The op hands down to the dispatcher. The dispatcher picks which kernel to run. And down to the bottom layer. At the base is the compiled kernel. The dispatcher launches it on the GPU. Your line, the op, the dispatcher, the kernel. You tuned everything above the kernel. The bottom layer has opened into a door. That compiled kernel is a boundary. Above it is PyTorch, the framework you have been tuning. The kernel itself is written in CUDA C, and PyTorch ships thousands of them. The boundary is where you would write your own, the door to the companion course. Step through the door. Underneath is the CUDA course's own map. The first piece, threads, blocks, and grid, that is CUDA 2.2. Warps come next, those are CUDA 2.3. The memory hierarchy is CUDA 5.2. Your first kernel is CUDA 3.2. And you start here at CUDA 1.1, why GPUs? Part 2, one op, one layer lower. Take one elementwise operation. Double every number in a tensor. In PyTorch, that is one line y equals x times 2. You never wrote a kernel and never named a thread. PyTorch picked the compiled CUDA kernel and launched it on the GPU for you. One PyTorch line. The compiled CUDA kernel underneath is chosen and launched for you. This is the same computation, one layer lower. It is the kernel PyTorch would launch. Written by hand in CUDA C, the global keyword marks it as a GPU kernel. Each thread computes its own index from block IX, block dim, and thread IX. A guard keeps threads in bounds. Then it doubles one element, one thread, one element. You are not expected to write this yet. That is the point of the door. The companion course teaches exactly this. Thread IX and block IX are CUDA 2.2. The global kernel is CUDA 3.2. Part 3, when to go down there. You have now seen the CUDA C, the trap is reaching for it too soon, before you have measured where the time goes. Almost every slow case in this playlist was a transfer, an idle gap, a D-type, or a launch count. Everyone was fixed in Python, not CUDA C. Profile first. A custom kernel is the last resort. Most slowness is fixed in Python. Quick check before we go. Your model is slow. Do you reach for a custom CUDA kernel or for the profiler? Pause and predict. The profiler. Every slow case in this playlist was a transfer, an idle gap, a dtype, or a launch count. All were fixed in Python. A custom kernel is the last resort. It is right only once a measurement says the kernel is the bottleneck. The full reasoning is in the course answers file. You can now measure PyTorch performance honestly with the timing lesson, and you can read where the time goes with the profiler. You can explain it. Dispatch, transfers, memory layout, launches, precision, and compile. You can fix most of it in Python. That is what the fixes across this whole playlist did. And when the answer is genuinely to write the kernel yourself, the companion CUDA course starts exactly there. That is the whole performance playlist. You can now measure, explain, and fix PyTorch. When you are ready to write the kernel yourself, the companion course starts at CUDA 1.1, Why GPUs.